So here we're going to talk about the chain rule, which is a case where we have functions layering with each other. So we can describe this as an inside function and an outside function. So like if we look at this m of x equals 2x plus 3 in parentheses raised to a fourth power, it's like at the outside of everything, we're raising things to this fourth power. At the inside, we're using this function 2x plus 3. So what can help too is if you imagine plugging in something for x, like what would be your steps for simplifying? So if we just plugged in like x equals 1, well, we'd multiply it by 2 and add it by 3. And that would take care of our parentheses there. And then we'd have this last step of whatever we get from that, we raise to the fourth power. So I know there's kind of multiple steps in there, but really we would focus on, okay, let's just simplify that. And then once that's simplified, then we do the fourth power. So that's the idea of an inside function and an outside function. So these are called composite functions, these functions that layer inside and outside. It could even be more than 2. We could have all sorts of layerings, but we're just going to focus on 2 for right now. So what we could do is describe this function m of x using f of x equals x to the fourth power, so that outside function of taking whatever's inside the parentheses, raise it to the fourth power. And the second function, g of x, which is this 2x plus 3, which we would simplify inside the parentheses first. So how we could describe this is, and how we would read this is f of g of x. So we have our outside function is f, and g of x is our inside function. So f of g of x. It's like how I would simplify this. If I have f of x is x to the fourth, g of x is 2x plus 3, and I wanted to find f of g of x. Well, what we're doing there is taking f of, and g of x is just equal to 2x plus 3. And our function f tells us take whatever our input is and raise it to the fourth power. And our input is this whole function 2x plus 3. So that's how we're seeing this layering of functions. What's going to be helpful in this section is recognizing what's the inside function and what's the outside function for when we're taking the derivative. So the chain rule tells us if we're taking the derivative of a composite function, it's like f of g of x, what we're going to do is first take the derivative of f, keeping our inside function. So g of x isn't going to change at all there. We're just taking the derivative of the outside function, keeping the inside function, and then multiply that with the derivative of the inside function. So derivative of outside, keep the inside, times derivative of the inside. So let's try this out. So let's go back to that 2x plus 3 in parentheses raised to the fourth power. So again, if I think of like outside and inside functions, on the outside of everything, we're thinking of this raising to the fourth power. So I could think of that as x to the fourth. And then this inside is where we're doing this 2x plus 3. So if I want the derivative, what I'm going to focus on is the outside. So this idea of raising something to the fourth power, what happens when I take the derivative of something raised to the fourth power? Well, the 4 comes down, we keep that base, and then that exponent, we go 4 minus 1, and that's a 3. Now the base that we're keeping is this whole function, 2x plus 3. So this right here is taking the derivative of that outside function, keeping the inside function. And then we're going to multiply by taking the derivative of the inside function, which is 2x plus 3, which would be 2. And with that, we're just going to simplify. So it's 8 times 2x plus 3 raised to the third power. So we could use more derivative notation here, but it's just kind of getting in the rhythm of this of derivative of the outside times derivative of the inside. It's just when you do the outside function, you keep the inside. Let's look at a few more examples here. So when we have a square root, we want to switch that to a rational exponent. So it's just kind of easier to work with. So we're keeping this inside of 4x cubed minus 9. But instead of a square root, we're going to describe that as a power of 1/2. So taking the derivative, on the outside of everything, we're raising to this 1/2 power. So if I take the derivative of something raised to the power of 1/2, the 1/2 comes out front to multiply. We have that base. And then for the exponent, 1/2 minus 1 is a negative 1/2. And that base, we just keep the same. So we're keeping our inside function. And then we're going to multiply by the derivative of the inside function, which is that 4x cubed minus 9. So derivative of 4x cubed minus 9, we're going to have a 4 times 3 with x to a 3 minus 1, which is 2. And then we're just going to simplify. So let's see, we're going to have a numerator and denominator here. So we have this 1/2. This raised to a negative 1/2 is going to show up as a square root in the denominator. So we're going to have a square root of 4x cubed minus 9. And then that 12x squared is just staying up here in the numerator. And then we could do one more step and simplify our fraction here. So 12 divided by 2 is 6. So let's just take that. Oh, I'll just put it over here. So that'll be a 6x squared over the square root of 4x cubed minus 9. And we're done. All right, let's see. Yeah, we'll just do this one more and then I'll have a second video with some more examples in there. And then, so I'm filming this video before going over the exponential and logarithm derivative formulas. So in those videos, I go over examples with the chain rule. Sorry, these got a little mixed up in the assignment. So with that, in the moments in those videos where I say I'm going to use the chain rule, maybe after watching this one, you could go back and check your answers and try those out using the exponential function and logarithmic function derivatives. But for this, we're just focusing on the power rule. So with this one, on the outside, we are raising things to the 20th power. So taking the derivative, I'm going to take the derivative, treating it like x to the 20th power. So 20 comes down, and then in parentheses, and then the new exponent will be 20 minus 1, which is 19. And then we just keep the inside. So that stays the same. And then we're going to take the derivative of the inside function, so times. Let's see, 4x cubed is a 12x squared for the derivative, so 4 times 3, and then that exponent of 3 minus 1. And then plus, let's see, 15 times 2, so 30x to 2 minus 1 would be a power of 1. And let's see, what are we going to do here? Can be nice is to take out common factors. I'm going to leave it just like this. There are things we could do. I could start like there's a common factor of 6 there that we could take out. There's even a common factor of x. There's even a common factor of x there that gets complicated with that. With the MyOpen Math homework, it's pretty flexible in terms of answers that you're inputting. Anytime that it says it's wrong is because there is simplification that we could do to go further. In this case, I'm going to leave it just like this. Maybe I'll do the one step of, I'm going to factor out a 6x from that spot. So what that would do is we'd have 20 times 6, which is 120. We'd have x coming out of there. And what that will leave me with in those parentheses is a 2x plus 5. And then I'm just going to keep that 4x cubed plus 15x squared to the 19th power. I just simplified it a little bit, getting a common factor out there. So when you factor out something from inside parentheses and you have something already outside of all of the parentheses, they get combined with multiplication. So that's how those ended up going together. And then you just kind of divide out of that factor. All right, so I'm going to split these up. So in the next video, I'll do some more examples with these, but getting more of our quotient rule and product rule in there.